Alright, y'all. So, real quick, let's review a couple of things. Number one, no iPads, absolutely no iPads today. So put them away. All you need is whiteboard, something to write with, something to write on, and your periodic tables. Alright. So, I think y'all pretty much got down what forms what types of bonds, but if I have multiple metals, what type of bond is it forming? Metallic. If I have a bunch of non-metals only, so no metals involved, what type of bond will it form? What type?
Covalent.
Covalent. And if I have metal with something else other than a metal, like a metalloid or a non-metal, or polyatomic ion is involved, then what type of bond will it form? Ionic. Alright, now, what's the difference between a covalent bond and an ionic bond? What happens to the electrons in an ionic bond?
They just take
electrons are given from the metals to the non-metals.
Right, so there's a transfer from the metals to the non-metals, exactly. And what about in covalent bonds? What's happening with valence electrons?
They share it.
They're shared. Alright, so we're gonna do electron dot diagrams today. And we're gonna do the electron dot diagram in an ionic bond, and we're gonna start talking more about covalent bonds, okay? So, first thing, let's make sure we know what the electron dot diagram we're gonna use. When I'm doing an electron dot diagram, it's taking into consideration those valence electrons. Now remember on the periodic table for our main group elements, so not the short stack, not the intertransition metals, not the lanthanide and actinide series, but the main group elements, 1A, 2A, 3A, 4A, 5A, 6A, 7A, 8A, or 1, 2, 13, 14, 15, 16, 17, 18, those group numbers, right? For your main group elements, the number in the ones position is the number of valence electrons we predict them to have. The exception to that is helium, which is in group 18 or group 8A, which only has 2 valence electrons. So that's the prediction based. We can use the periodic table to predict the number of valence electrons. When I am doing electron dot, I'm going to use the symbol of the element, and I'm going to use dots to indicate the number of valence electrons. Somebody give me a main group element. Just give me the name or and symbol of a main group element. Sulfur. All right, what's the symbol for sulfur? S. How many valence electrons does sulfur have?
6.
Sulfur has how many valence electrons? 6. It's in group 6A or group 16. The number in the ones position is a 6. So we predict sulfur has 6 valence electrons. If we do the electron configuration for sulfur, which will be 1s2, 2s2, 2p6, 3s2, 3p4, when we add together the 3's, we will see that there is a total of 6 valence electrons. 2 in the 3s and 3 in the 3p. So 4 to 3p, so 4 plus 2 is 6. But anyway, how many electrons can be in an orbital domain at one time? What's the maximum number of electrons that it can hold at one time?
8.
No. 2. 2. Remember, the s orbital exists in one plane. There's only one plane for the s orbital, so it has a maximum of how many electrons it can have? 2 in the s. The p orbitals can exist in 3 planes. 3 different planes, x, y, z. Each one can hold a maximum of 2 electrons. So how many total electrons can I have in a p? 6. D has 5 planes, right? So what's the maximum electrons I can have in D? And F has 7 planes. So what's the maximum electrons that can be in an F? 14. But each one of them can only hold a maximum of how many electrons? 2. So if I look at the symbol for sulfur, there's a top, a bottom, a left, and a right. There's 4 different places where I can put dots. So 4 different planes, maximum of how many electrons can go in each one? 2. So what's the maximum number of valence electrons I can put around this element? 8. Now, what's the magic number for valence electrons? 8. All right, we know there are always exceptions to the rules. We're teaching the rule, not the exception. Okay? Now, what do we know about electrons when it comes to them pairing up?
They repel from each other.
we know they repel because they have negative charges, but what about them pairing? Do they pair all the time, or when do they pair up?
When they need to.
When they have to, right? There's nowhere else, they only pair when they have to. So, let's think about sulfur. We said sulfur has how many valence electrons? 6. Sulfur has 6 valence electrons. There's 4 places I can place these valence electrons, right? So, 1, 2, 3, 4. They want to be as far apart from each other as possible, so I'm going to go 5, 6. Notice I did not do this. I didn't do sulfur like this. Why would this be incorrect?
Because they still have space. to,
There's still space, and at least one of those pairs don't need to be paired up, right? They can spread out. I also put my pairs as far apart from each other as possible. Now, it doesn't matter if I put them like this. I could have done this as well. It's the same thing. The key is to make sure that I'm only pairing electrons when I have to, and I only have 4 places to put them. I can't do this. I can't just go up this. There's only 4 places to put them. Okay, top, bottom, left, right. Y'all follow? Yes.
Could it be like or like write down the S, like, right? And then
You mean
do
something like
one-
this? Like there's
Yeah,
one
yes.
here. You want to put these pairs as far away from each other as possible. Okay? Because remember, there is the electromagnetic field being produced by the spins of the electrons. Remember, one has an up spin, one has a down. So they want to be as spread out as they can possibly be. Okay? Now, technically, because you write it that way, yes, but we want to try to illustrate as much as possible the true behavior of electrons, which is to get as far away from each other as they can be. Okay? Now, is sulfur a metal or a non-metal?
It is a non.
It's a non-metal. So now give me a main group element that is a metal and tell me the valence electrons.
Magnesium.
Magnesium, okay? What's the symbol?
Mg.
Mg. And how many valence electrons does magnesium have?
12.
How many valence electrons does magnesium have?
2.
2. Now, some people will do it like this. I personally will never do that unless it's helium, because that's not, but magnesium has more than one shell, so I'll never put them like that unless it's helium. So, I have 2. Doesn't matter if I went top, bottom, left, right, they're not next to each other, they're spread out. Alright, now, this is for the actual atom. But what happens if it's an ion? So, this is a non-metal. Non-metals form what type of ions? Cations or anions?
Cation.
Non-metals form what type of ions? Anions. A negative ion, which means it does what? Gains or loses valence electrons? Gains. Because remember, it becomes more negative. So it gains electrons. So, how many electrons does sulfur need to gain in order to satisfy its valence shell? 2. So what's the oxidation number? If sulfur if sulfur becomes an ion, what is its oxidation number?
-2.
-2. So when I draw the electron dot for the sulfur ion, I'm going to repeat what I did, except this time I'm going to give it its octet. And I'm going to indicate that it's an ion by putting it in brackets and putting its charge outside of the brackets. Are y'all following? Y'all following? So on your board, well, no, not yet. Let's do the metal. Magnesium. What type of ion does magnesium form? Is it a metal or a non-metal?
Metal.
What type of ion will it form?
Cation.
A cation. C, a positive ion. So it became a cation by doing what? Losing or gaining electron?
Losing.
Losing. It becomes less negative. So it loses valence electrons. How many valence electrons does it have to lose?
2.
2. So, I'm gonna put it in brackets. Do I put any dots around it?
That was the loss.
No, because it lost them. So what am I gonna put out here then?
Plus 2.
Plus 2. Because now it has a charge of plus 2. Y'all following? Are you sure? Alright, so this is the atom, that's the ion. This forms an anion, meaning it gained valence electrons. Remember, the dots represent valence electrons, not all the electrons, just the valence. The nonmetal gained valence, so I'm going to show it that it gained valence. And show the charge to indicate how many electrons it gained. The metal forms a cation and it lost valence electrons. So I'm going to show the loss and the charge to indicate how much it lost. Y'all with me? So far so good. Alright, now, let's take these same 2 elements and let's combine them. Let's combine magnesium and sulfur into a compound. If I combine magnesium and sulfur into a compound, what will its name be?
Magnesium sulfide.
Magnesium sulfide. So these 2 together are going to form magnesium sulfide. What is the chemical formula for magnesium sulfide?
MgS.
Say it again.
MgS.
MgS. Why is it not Mg2S2?
Because it,
You gotta put it in the lowest ratio, you gotta simplify it, right? So, remember you figure out the oxidation numbers, you swap and drop. But it would have been Mg2S2, so I need to simplify that, put it in this lowest ratio. So the actual formula is MgS. So now let's do this reaction using electron dot. I'm gonna have to show it. So I'm gonna put magnesium with its 2 valence electrons plus sulfur with how many did it have?
6.
6. And then it's going to give me magnesium with a 2 plus and sulfur or sulfide, because we changed the ending of the name, with 2 minus. I'm going to show you what happened with arrows. There is a what with the electrons? Are they sharing or are they transferring? From what to what?
The magnesium to sulfide.
So the direction of my arrow matters. So I'm going to say the magnesium gave electrons to the sulfur. I'm indicating that using my arrows. Okay? So there was a transfer of valence electrons from magnesium to sulfur. Now notice that this actual ionic compound, is it really bonded or is it just strongly attracted to each other? Strongly attracted. The only true bond, guys, is a covalent bond, where you're sharing valence electrons where those orbitals actually merge or fuse, overlap with each other. Here, there's just an attraction between ions. It's a very strong attraction, but it's not really bonded per se. We still call it an ionic bond though, okay? The only true bond though is that covalent bond. Everything else are attractions, and the attractions get weaker as you move to different types of bonds. But ionic bond is a very, very strong type of attraction. All right, now, this is a simple one where the ratio was 1 to 1. But let's do one where the ratio is not going to be 1 to 1. Okay? We're going to do this one on your whiteboard before you put it in your notes, because I want to make sure that you have it right before we do it. So we're going to do name, formula, and electron dot. We're going to do this one together. The next on through the whiteboards, and then the next one you're going to do on your own without me talking. So when I name this, what goes first?
The metal.
The metal. So what is the metal?
Aluminum.
Aluminum. and sulfur is a nonmetal. So what type of bond is gonna be formed? Metallic, ionic, or covalent?
It's gonna be an ionic one.
Ionic, okay? So on the count of three, let me see the name. I just wanna see the name first. On the count of three, let me see the name. 1, 2, 3. Let me see. Cool beans and awesome sauce. It is aluminum sulfide. Why is it aluminum sulfide and not up ALUMINE? Okay. Oh, Jesus. Why is it aluminum sulfide and just not aluminum sulfur? What do we do with those nonmetals?
You change the.
Change the name. You change the ending of the name. All right. What's the formula for aluminum sulfide? Write it down. The formula for aluminum sulfide. You have to have a second. Here you go. 1. I love how y'all don't panic when I say 1. 7 people like, no, wait, no.
I'm panicking.
This video is for 7 periods, that's why I say that. 2. 3. Let me see what y'all got. Nice, nice, nice. The formula is what? Al2S3. Where did this 2 come from?
The sulfur.
The sulfur, the oxidation of the sulfur. And where did 3 come from?
Oxidation of aluminum.
Oxidation of the aluminum. Alright. Electron dot. Do it. Try the electron dot. I believe I can fly. I've been feeling like a bad chick all day. You know what? Honey wasn't great.
Of course.
Oh, that's so good.
2.
You ready? We need more time.
That's fine.
When you lock in, you lock in. I like it. Give you 1 more minute, then we're moving on. Gonna take about 20 to do the last part. What's saying? Leave out here at 35?
Yeah, yes.
Okay. Alright. Whoa, that was a quick minute. 1, 2, 3. Let me see what y'all got. Alright, let's work through it together. Put them boys down. Alright, now. I have aluminum and I have sulfur, right? How many aluminums do I need in order to do this? And how do I know? How many aluminums do I need? 2. How do I know I need 2? It tells me right there in the formula. You following? How many sulfurs do I need? 3. So let's start there. Oh, not there. Let's start with my aluminums. Tell me what to do.
A, write down the
The symbol, which is what?
A,
Al. How many valence electrons does aluminum have?
It has 3.
It has 3. How am I gonna put those? Are any of them doubled up?
no.
No. Alright, so I'm gonna give aluminum is 3 valence electrons. This is my choice to go topped up right. Okay, as long as you got 3 and they not doubled, it doesn't matter. I need 2 of these though, so that means I gotta repeat the process. What's this aluminum combining with?
Sulfur.
How many?
Sulfurs.
Oh, it's 30.
3 sulfurs, okay? So, I'm gonna put my 3 sulfurs here. How many valence electrons does sulfur have? 6. How many are doubled up? How many are in a pair?
It's
2.
2.
2 of them are in a pair and 2 singles. This is my choice to go top, bottom, left, right. Your choice is yours. This is my choice. Before somebody asks me if theirs is wrong because they put theirs in a different location. This is, I do everything the same way every time so I don't forget how I choose to do it. Alright, now, what type of bond are these guys forming with each other?
An
An
Ionic bond. So there's gonna be a what of electrons?
Transfer.
Transfer. From what to what?
Aluminum to sulfur.
From aluminum to sulfur. So, I'm gonna give this one here, this one here. It still has 1 to give. So I'm gonna give it here. And I'm gonna give this one here. There's 2 left. Oh, great, because there's only 2 more that needs to be given. Do you see why I needed 2 aluminums and 3 sulfurs?
Yeah, because it fills
Yes.
They feel, right. Now, I'm gonna draw my arrow because they're reacting with each other. This arrow means yields. Whenever you read a chemical reaction, you read this arrow as yields. Okay? What does it yield for me?
They put bracket and then.
Bracket. Talk to me.
Minus.
Aluminum, what's its charge?
Plus 30.
Okay. And then, what is it bonding with?
Sulfur.
Sulfur, and what's its charge?
-2.
-2. Now, there's 2 ways you may see this. I'm gonna show you the way that I prefer to do it because I don't like to write a lot of stuff. I'm just gonna put my subscripts. Let's say that there are 2 of these and 3 of these. That's what I do because that indicates I know what I'm talking about. You may see it this way. I'm probably gonna see it this way more often because not everybody's as lazy as me. Where you're actually gonna have the 2 and the 3. Oh wait, what did we forget on the sulfur? The valence electrons. Okay, so that's indicator that there's 2 aluminum ions for every 3 sulfur ions. That's what this is indicating. Okay, that's the electron dye. Now, I only care about the oxidation numbers for ionic bonds because the only way to form an ion is to gain or lose electrons, which means I need to know what the charge is for this atom if there is a transfer of electrons. If I'm not doing ionic bonds, the oxidation numbers don't come into play with this, okay? So let's go ahead and do this one, you guys, on your board.
I have a question. Will there ever be like a time where there's a valence electron left over? Or will it always like even out?
What do you mean, like,
Like,
what do you mean between a metal and a non-metal?
yes, in a.
No. But it can happen with non-metals, which is how we get polyatomic ions. So it can happen when non-metals come together, they form polyatomic ions, but when metals bond with non-metals,
It will always, okay.
yeah. Name, formula, and electron dye. Hop to it. I wanna erase what you got on the board first, so we can add the other stuff onto it. You sleep, it's black. Don't do that for real, I'm just playing.
We gonna make it work, don't worry about it.
Thank you, Marcel. He's over there struggling on how to get it out. I'm just saying. Yeah, you might want to get rid of that name too, because we got chlorine and magnesium. There's no aluminum or sulfur up there, just, you know. I was zoned out. Ooh. And just so you know, I intentionally put these on the board in any random order because on the quiz, people were writing the names in the order the elements were written in the problem, and I'm trying to make sure you know to always put, if it's an ionic gun, to always put the metal first. So I intentionally put it where it's not, to force you to do that skill, BTW. Alright. Here we go. Oh, one. A two. Woo! I still see some marks. I'm trying to make sure I give everybody an opportunity before I call three. And three. Let me see. Alright, let's do it together. What is the name of this compound?
Magnesium chloride.
Magnesium chloride. Cool beans and awesome sauce. What is the formula?
MgCl2.
MgCl2. Alex, you killing it on this. You must really like this or get it. Alright, I love it. Alright, electron dot, tell me what to do.
Okay, if you can put
Write Mg and then OCl, and then you put 2 dots away from each other on Mg.
Okay.
And then for Cl, you put 7 dots away from each other, yeah. And you put another one.
Do another one, okay.
You also put 7 on.
and
And then you put the arrow.
one valence electron
From what to what?
from magnesium to chloride.
Okay. Okay. What does that yield? Talk to me.
That yields a
Mg.
bracket Mg
Okay.
plus 2 plus chlorine
Cl.
2.
What's the charge in the chlorine?
It's one
Negative.
Okay. So you said to put the negative, right? We have to put the charges even if we don't put the number. And is it just one chlorine?
2 chlorine.
Two of them? So we
Put
can
out
do
the
it.
subscript.
Right, subscript or I'm just gonna go ahead and put the 2 chlorines. Okay, see how that balances out the charges, 2 positives and 2 negatives? Okay, cool beans?
Yes, yes.
Alright, moving on. Now let's talk about our lovely covalent bonds. Covalent bonds, what does co mean? To share, right. And what are we sharing in this case?
Electrons.
What type of electron specifically? Valence electrons. So we are sharing valence electrons, forming a true bond. Now, there's more than one way to share. My sharing can be unequal or my sharing can be equal. I don't have to equally share anything. We can figure that out by looking at electronegativity chart, which tells us how likely something is to attract those electrons. And if the values are very close together, they're probably going to share equally. But if there is a big difference between those values, they're gonna share unequally, or if it's a really big difference, they can actually steal the electron, pull it away, form an ionic bond. So with my covalent bonds, and we'll look at the chart tomorrow, but my covalent bonds, there's a specific name for the type of sharing that happens. If there is unequal sharing of electrons, what type of covalent bond is that?
A polyatomic?
No, covalent bonds. There's two types of covalent bonds, polar or non-polar. So if there is what does un mean? Not. Now, the two types of bond are polar and non-polar. What does non mean? Not. Do we use double negatives? No. So never put the non with the un. So if it's unequal sharing, then what type of bond is it? Polar or non-polar?
Polar.
Polar. And if it is equal sharing, what type of bond is it? Non-polar. Non-polar. When we talk about polar, we're looking at the molecule as a whole, and when there is a polar covalent bond, the molecule appears to have one end that's slightly charged negative and another end that's slightly charged positive. Like a magnet has poles, opposite poles. That molecule appears to have opposite poles, so it can make them sticky. It's one of the things, sticky, which means they go bond to other things. One of the things that makes water so special. Now, with covalent bonds, there's more than one way that they can bond because they're sharing valence electrons. If I have something like hydrogen, hydrogen is a diatomic molecule, right? Remember bromine, bromine, oxygen, hydrogen, chlorine, iodine, fluorine, and nitrogen are all diatomic molecules, meaning in nature, they come in pairs, okay? So, we write that down. Bromine, oxygen, hydrogen, chlorine, iodine, fluorine, and nitrogen. When I see them in nature, they're found in pairs. Remember that eighth one is sulfur, and sulfur comes in the octet, it's 8 of those. So, bromine. Now, let's look at hydrogen, nitrogen, and oxygen, specifically on how they form bonds. You can predict how many bonds a non-metal can make based on the number of valence electrons it needs to be satisfied. How many more valence electrons does hydrogen need to be satisfied? 1.
Oh, yeah.
So that means hydrogen can only make one bond. That's the maximum number of bonds it's going to make. So when hydrogen bonds to another hydrogen, it's making a single bond. Lines represent bonds. This is a single bond, meaning that they are sharing a single pair of valence electrons. They're sharing one pair, okay? Let's look at something like oxygen. How many valence electrons does oxygen have? 6. How many more does it need? 2. So how many bonds will oxygen make to get that 2? 2. So when oxygen forms its diatomic, it's going to form a double bond to another oxygen. So what does that mean? How many pairs of valence electrons is it sharing? 2 pairs. It's going to share 2 pairs. Okay? Now, let's think about nitrogen. How many valence does nitrogen have? How many does it have? 5. How many more does it need? 3. So it's going to make what type of bond? Triple bond. So that means they're sharing how many pair of valence electrons? 3 pair. They're sharing 3 pair of valence electrons, okay? So when I share, I can share with single bonds, double bonds, triple bonds. Carbon can even make a quadruple bond. Carbon has 4 valence electrons, needs 4 more if it's bonded to another carbon. It can make a quadruple bond. It can share 4 pair of valence electrons. Now, when we are dealing with our non-metals, because they are sharing valence electrons, there is no transfer. So let's take water. Chemical formula for water is what?
H2O.
H2O. So hydrogen has one valence electron. There's two of them. The oxygen has 6 valence electrons. There's only one of them. There is no transfer. I am not going to show arrows to transfer. Instead, I am going to show them sharing. Now, hydrogen can only make one bond, so it can't be the center. Because if I put it in the center, once it bonds to one thing, nothing else can bond to it, right? So my central atom has to be oxygen. So I'm going to put oxygen in the middle, bond it to the hydrogens, and then add in the other valence electrons. Notice that here, they are sharing those valence electrons.
So it's not like quality.
Not really. They're sharing. Everybody clear?
Yes. It's 10
I see the time, I'm gonna sit 32. Now, when we name covalent compounds, we use prefixes. You've taken geometry, you know what they are. 1 is mono, 2 is di, 3 is tri, 4 is tetra, 5 is penta, 6 is hexa, 7 hepta, 8 octa, 9 nona, 10 deca. Those are the ones you have to know for Gen Chem. We only use mono on the second element. For instance, what is this right here called? Carbon monoxide. We don't say monocarbon monoxide, okay? So if we look at water, let's give water its scientific name. How many hydrogens are there? 2. So I would say what? Dihydrogen.
Oxide.
How many oxygens are there?
1.
1. You have to use mono for the second element, so I would call it monoxide. Remember, for the second element, we changed the ending of the name to I. So the chemical name for water is dihydrogen monoxide.
Wait, so
With covalent compounds, the name tells you the formula, and the formula tells you the name. If I told you you had carbon dioxide, what's the formula for carbon dioxide?
CO2.
CO2. That's the formula. Because carbon dioxide means 1 carbon, 2 oxygens. Okay?
And you don't put mono if
On
it's
the
like-
first element.
Okay.
But mono has to go on the second element. Mono does not go on the first element. We're gonna pick up with Vesper, which is valence shell electron pair repulsion, on tomorrow. And that's it for today. Good job, guys. Lila.